Um, Good day to all of you. So, welcome back to our session for today. So, as a reminder, if you are not yet a member of ICU-DDR and you are working in a tertiary institution as a teaching assistant, faculty member, and the likes, please feel free to join us. So, membership is for free, and feel free to share with your colleagues as well. So you can join by logging on to our website at www.icuttr.org, and also for you to be able to access on-demand videos like resources, recordings of previous events. You can see the link in our website as well. So welcome to the second to the last session of our workshop. We're very happy that you are here with us and that you continue to support this activity. So as a reminder, so microphones are muted. So if you have questions, please type it in the chat box. We would also like to invite you to our upcoming webinars. So the information has been pasted into the chat box. So if you have questions, do it. And then for today, we're going to continue where we left off yesterday, which is we are working on a real data set that we downloaded and that hopefully you have uploaded. So if you have questions or anything, please put it in the chat box and we will monitor it, and if it needs to be immediately addressed, we'll call Dr. Cosgola's attention. So now, without further ado, so if you have joined us for the first time today, we have sent like information about uh, using R. If you don't have it, if it's your first time and you're having difficulty, please send me a private message or Caleb and we'll help assist you. So without further ado, we're going to turn you over to Dr. Cosgola for the continuation of the session. Dr. Cosgola.
Okay, thank you. Thank you so much, Rana. Um, let's uh, let's go back to where we stopped yesterday. And so we were using a data set that, remember, so we downloaded a data set. So we found it from a website, a data repository. And and then we started writing all the codes, right? So we just put the data set inside the project directory, and then we imported that into our workspace, and then we renamed the data set because it did not look good. The column names did not make any sense. And then we converted them into the correct variable types, right? So using these conversion functions that's available in our base code, right? So that was actually so yeah, so then we also did imputation. So we did impute all the the continuous variables, um, and sorry, all the integer and then and any decimal type variables. We used the median, like imputation function. So just use the median to impute it. So that's what I did. That's what we did here. And the next thing that we have to do is to impute the categorical variables. So we saw in the data set there were some missing values. For example, see the occupation is missing here, right? So how do we impute that? So um, so I'm just doing the basic things here. Okay, so you have to understand that there are lots of advanced, more sophisticated, and also like better methods of performing this task. But in this context, we won't cover all those things. Like in general, I did not cover any of the advanced topics in any area. So it's just all basics. So because you need to know the basics first, and then actually you can teach yourself all the advanced things, because when you know the basics, the rest is actually quite simple. Okay. Uh, so let's go to the imputation of these categorical variables. So we have an issue because now, median is a function that's available in our base code, but we cannot use that for categorical variables, right? It doesn't make any sense to compute a median of a categorical column, right? So that would not make much sense. So what would make more sense? So for example, so if you look at the occupation, we just find what the mode. So of that means, for example, what's the highest occurring occupation, and then we replace the missing values with that mode value. But unfortunately, in our base code, we don't have a function like this um, to compute mode easily. So first, we need to write that function, and then we need to recall it. So call it within the imputation function, what we do here. Okay, so let's say function to find mod. Okay, so I really need you to get into the system, your R code, and then make sure you can open it and then you can run it. Can you please follow these instructions and do it with me?
So Dr. Kusgola, maybe we should give them 5 minutes.
Yes, sure.
Okay, and if you guys, okay, are finished and we can proceed, like after 5 minutes, please give us a thumbs up. If you need a little bit more of time, please let us know in the chat box. Thank you. Some of you might just be running your R and you have to load your libraries, return to the previous data sets yesterday and the likes. Okay, thanks, Dr. Tiru. Let's wait for the others. 3 more minutes. Okay, is everyone ready? Can we move on?
Okay, yeah,
Okay,
sure.
thank you, sir.
Okay. So, like you can write a function in so many different ways. I'm not expecting, through this course, I'm definitely not expecting you to be able to write your own functions. Okay, so like I said earlier, like this function is not unfortunately available. So I'm just going to write a basic function, which is not going to handle all the cases, but most of the cases it will handle, like a simple function that we can use. We can also utilize all the features and functions available in our base code to do this. Okay, so let's write a function. So first we have to give a name to the function, right? So let's say get mod or find mod, however you want to write it. name your function. So this is the function name that you're going to call everywhere from here onwards. And then you have to use function, define it as a function, and then you have to give the arguments that you're going to pass through the function. And then within brackets, you're going to tell, what the function needs to do. Okay. So, so the first thing to get mod is actually to find all the unique values. Okay. So I'm going to give you I'm going to give it a name, right? So we have to give a name. So find unique values and then store them in a variable. So let's say unique variables. Okay. So this can be easily done using the base function. So there's a base function to find unique. So you can just simply call it right here. See? So if you call this, you will find the unique value of v. So v is going to be the vector that contains all the data within our column. Okay, so if you have a column, so for example, right here, so occupation. So v is all the elements in this column. So it's a vector. Okay, and then next thing that I want to do is we have to find the number of occurrences of these unique values, right? So that's the next step. So how do we do that? So we are going to use a simple command in R to count the occurrences of each unique value. Okay, so let me write it. So you don't have to really understand all these things, but because this is not basic. So which max is the maximum or minimum? So it's going to find the maximum or the minimum. And let's say we want to find the matching pairs of the unique values and v. So that way we'll find for each index, it will define, what unique value it is. So in order to do that, so I'm going to use match let's say, yes, match function. So it's going to match the first variable to the second variable. So second variable is actually this unique v. The first one is actually v. So all the elements, right? So it will identify all the assigned unique values identical the point what is the unique value for each row in that our columns. All the if you get our entire column, so there's each row, right? For each row you will identify what the unique value is. So you have to use this. Let's copy this.
Sir, would you mind copy pasting that in the chat so that they can analyze it further on later?
Yeah, so yes, I can do that, but let me finish it. Okay, so once I'm done with the function, I'll share it again.
Thank you.
Yeah, sure. So so then we are going to tabulate this. So if you tabulate it, so then we can find the max and the minimum. Okay, so I'm going to use tabulate function. So this will return definitely this is going to return the 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 maximum occurrences of the unique values. So it will for each unique value. So it will count. So because uh, it's through the tabulation process, it's going to count, right? So remember, we had that table function. So it's similar to that. This tabulate will count the occurrences, and it will give the maximum occurrence. So this is the function that that we are going to use. So once this is done, we have to again uh, um, find the unique value of this. Okay. And that's what's going to this function is going to return. So maybe most of you find it difficult to understand what this does, but you can easily use this function, so you don't have to know what this is. And I'm pretty sure if you also search, in Google, how to find mod, it will give you like multiple functions, not just this. Like this is something that I thought of, but there will be lots of other functions that you can simply copy and paste. You don't have to understand it. Okay, so this is not something that I expect you to understand. So this should work. So basically, like if you just copy and paste into your environment, so this entire thing should work. Okay, so let's test it. If I wrote it correct by calling it. Okay. So now, before I give the function, I'm going to test it. Okay, because I want to make sure it's right. So sometimes, I mean, it's just a very simple function. I maybe made a mistake, right? Or maybe there's a mistake, that when I typed it, or maybe in my logic, right? So let's try to see if it's correct. So now, for categorical variables, if you go back here, so what categorical variables that we need to impute? So the first thing that we find here is work class, right? So let's see if there's any, see, 20 record, 28, it's missing here, right? So let's try to see if my function works. If not, I'll have to go back and fix it, but I'm pretty sure it's fine. So adult data, and then work class, and then similar, if you only have to impute missing values, right? Only the missing records is .na adult data work class. We are going to use that get mode function. Okay, so we don't have a mode function, so I'm going to call get mode. See that get mode function is already here, and I'm going to pass V. So we have to assign what V is. So in our case, V is this, right? Adult data dot work class. So if I print this, this is V. Okay, work class. So you can see all these values. Okay, so basically it's adult data, that entire column, work class. So so if I did it right, so this should work and do the imputation, right? So let's run it and see if it worked. Yeah, so 58, now it's being filled. See, it's private. So private seems to be the mode, right? So that looks like many people have private jobs. So in this, in this group. So it worked. So let me give you the function so you can test it. And I also give you a few minutes, okay? So that you can execute this and make sure it runs well in your environment. So I'm going to give you a few minutes, okay? So again, like I'm not expecting you to understand how this function works because there's a little bit of like, math involved here, and not all of you are well trained to do like, mathematical stuff in advanced level. So that's not something that I expect you to do, and nobody expects you to do that. So if you want in the future, if you have to use a function, if you don't know, how to write it, always you can search in Google, what's the function to do this in R, and then there will be lots of examples and some other else developed. You can simply use that. And you can also, if you are comfortable, you can learn how these functions work and then write your own. Anybody can, be trained to do anything. So that's my, slogan. So if you really want to learn, yes, you can learn it, but it's not necessary. Can you please let me know when you are ready?
Thumbs up, please, if you guys are okay. Still waiting for them. Let's see.
Right. So those who are already done with this, so let's go back to your data set and see what the next categorical variable is, right? And then you try to write the code. Again, like I said earlier, so it is extremely important for you to do these steps. No matter what you do, you need to learn how to clean your data, do the imputation, and then only you'll have a really clean data set that is good for your hypothesis testing, right? So how everyone is doing? Are you struggling or is everything fine? I actually prefer to communicate and know what's happening, because at this is a really important stage. Want to make sure we all are on the same page.
So, Dr. Cosgola, with your permission, I'm gonna give them the capacity to unmute themselves. Is that okay?
Yes, that is absolutely
Okay.
fine, because we have a small crowd here, right? So that's fine. Okay, yeah, so it's
Okay.
it's fine. Yes.
So guys, if you want to unmute yourself and if you have questions, much easier now because we're a smaller group. Feel free to ask questions and address your comment to Dr. Cosgola. Thank you.
Yeah.
Okay, you're most welcome.
Yeah, yes. You're welcome, Grace. Anytime you can talk, whatever you want to ask. Like, I'm here to help. Whatever, I don't know everything, but I'll do my best to answer. So hopefully, if time permits, I can also teach you a couple of additional things like next week, some little bit of advanced things, not really going lots of um, complicated tasks, like at least to develop nice plots and maybe do some exploratory analysis. A couple of things that I can show you. I won't go into details, but at least you'll have the code, and then if you're interested, you can explore them further. Okay. Okay, so I hope we are good to proceed, right? So let's see what the next variable is. So I think we have education, right? So yes, education. So let's rewrite the whole thing for education. So it's really easy to like type here. So when you start typing at ADUL, and then you will see like, this is popping up. So you just use your tab um, and and then it will fill up. It will fill the rest of the the word, the entire thing, and then you use $sign, and then the next variable is education, right? So you start typing edu, and then whatever is highlighted here, so you can see if you hit tab, it's just gonna be selected and filled like that. Okay, so it's simple, and then you have to check um, if only you have to fill the missing values, right? We don't have to fill anything that's already there, right? That would be erroneous. We don't need that. Those are the real values that people entered. If there's anything missing, so that's what this is.na function is doing here. And then you just do the same. So we have to find the missing values in this column, right? So education. You can see how easy it is to type things here and faster. So when you learn, I'm not typing it faster, but I can actually type even faster. When you get when you do this often, you learn how to do it faster because they made this auto filling thing. So it's really easy. Okay. All right. So so that's the next one. And then let's do the rest also, right? Education. And education number, we already imputed that. And then this one, right? Marital status. So let's do that. Yeah. So that should be the next one. So we need to test again, if NA. And using our function. Okay. And then what is next?
Occupation.
Is it occupation? Yes, it's occupation. Yes. So let's do that. Sorry. So I'm assuming you're following me, right? This is really important. Make sure you can you can follow me. So when you start doing this, you will start feeling more and more comfortable with programming because you feel confident, right? So that's really important. You need to know what exactly you're doing, and it's when you know what's happening behind the scene, it gives you lots of confidence, and it's hard to make a mistake while doing these things because you know what's happening, right? Yes, trust me. If you follow this, all my lectures, what I did, thanks to all the teachers that I had in the past, and also what I learned by myself. So I compiled all these things and I gave it to you. Hopefully, it will be helpful, but it will only be helpful if you just um, follow it, do it by yourself. What is next? Relationship, right? Okay. So without looking at my screen, try to do it. Okay. And what is next? Race. Right. So we have race, gender, and then native country. Okay, so there is an error here, right? So native country should not be like this, right? So something must have happened here. I don't know. It's fine. Let's rerun this and see what's going on. Because something must be happening here. Let's see. Hours per week, native country. Let's see where things go wrong. Oh, so this is the problem. See, I made a mistake here. So I have native country here as a factor, and then I'm replacing that with income, so which is not correct, right? So we cannot do that. So let's fix it. So this is from yesterday. So this must be income, right? Income. And then this must be native country. Let's see how. Work class. Okay, hold on. Okay. Let's see if it's correct now. Yes, now it's correct. Sorry about that. See, like, anybody can make a mistake, with some typing, like copying, pasting. So you got to be careful. So you have to recheck your work. Okay. And so after relationships, we have, please go back and change if you have the same issue. Okay, I'm pretty sure you did it right. It was my mistake. And race, right? So adult data. So test is dot. Okay. And then that should be gender, right? Gender, gender, native country, and income. And that's it. So I'm gonna copy paste gender. Native country. And then you have income. Okay. All right. So yeah, so this should work, and this should actually um, take care of all our missing data issues. So how do we identify, if there's no any missing data? So we can check for any remaining missing values um, using that isNA function. Okay, so basically we can use the same isNA function. So right here for the entire data set, right? So here we only use isNA for this column. Within this column, we check if there's any NA, if there's any NA values, that means like missing values. And we can do the same thing for the entire data set, okay? So checking for any missing, any remaining missing data set. So we use is.na, and then we give the entire data set, okay? So if you run this, you will definitely get it, get the number of missing, it will show you like an array of missing values. So say it's saying false, 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 false. So if you get the sum of this, so sum will only count the true occurrences. And then it will say 0. See, there's no missing values here. So if you use sum function and isNA function, and then you say entire data set, and sum is going to count number of true values, because true is 1, right? So true means for the computer, true is 1, false is 0, right? So it will count all these things. These are actually 0 for the computer. So whenever computer sees false, that's actually 0, okay? So if you see the sum is 0, that means that's not true. That means missing, there's no any missing values there, okay? All right, so what is next? Let's summarize. Let's see a summary of the data set. And it will show you all the statistics, right? So the minimum, median, maximum, mean, and all those things are given. And then for categorical variables, so it's going to give you the count, right? The frequencies of each category. So remember, so this is the mode, right? You can see private, we have 22,696 records. So what does that mean? So that means that's the mode, right? So maximum, occurring category, right? Category. So that's why we assign that. So there is labeling issue here. So you can see. So there is this is not missing, okay? So should not be missing, because we didn't find any missing values, right? So let's see if there's any missing values in this column. There should not be. So it should be a naming issue somewhere of the category itself. Sorry. Zero. So there's no missing value. So they, when they assign categories, there must be like, so this could be some sort of a work class that they haven't identified properly. So that's probably why it's showing this way. Okay. So, but there's no missing values in the data. So, so this is this is the issue with the existing data set. I'm not going to try to fix it because it's not really important for us. But as long as we know, if there's no missing values using this, we should be good. Okay. So, but if you have to rename your categories, so then that's a different process. That is something that I have not um, covered. Okay. So, but I don't. It's something that you have to do rarely because usually we don't change those original responses of people. So we just keep them intact. Okay. Okay, so be aware that every time when you have someone else's data set, like we call it like secondary data, right? We always have to deal with some data related issues. Even if we do our best to fix all the issues, there's still going to be some issues. So there's no perfect data set, even if we do our best to make it perfect. All right, so we should be good now. So I'm not going to introduce you to any of the um, the advanced functions. So um, we should be able to execute. So can you please check and make sure you can run all these things um, in your environment, please? I can give you a couple of minutes and you can unmute yourself and then let me know if you have any questions. Okay, so are you ready to move forward? Yeah, so let's try to see if there is any outliers. Okay, so outliers in the data could be really troublesome. It could give you some issues. So, for example, outliers are actually like kind of unusual observations that are not within the range. For example, if you get this age, so you might see somebody of let's say having like 10, 10 years old, right? This won't make sense because usually you don't collect responses from the younger people like that, right? So you cannot go one by one and try to understand if there's any outliers. So there's lots of hundreds of different ways to determine outliers, find out if there's any outliers in your data. I am going to just use um, a plot. Simply, we can plot the data and see if there's any outliers. Okay, so we can just use the function ggplot function, plotting function within the ggplot2 library to determine if there's any outliers. Okay, so we can simply use like box plot I'm pretty sure you are familiar with box plot. So let's try to check. So make sure you have ggplot installed, right? So you need library ggplot2, right? And then, so first we have to give the data set, right? Remember? So first thing is, the first argument for this function is adult data. Sorry. And then we have to identify the x-axis values and y-axis values, right? So we use this AES function, remember? So that's what we did within ggplot. We have to identify what the x values and y values are. So here, in adults data, so x values are these column names, but by themselves, right? So we can just since we don't have a column name values, we can just leave it blank and it will automatically identify like this. And then you have to identify the y values. So here, let's see, if age has outliers. Okay, so that's our first task. So we are going to have a box plot. So if you try GOEM, and it will show you all kinds of plots available. You see, there's lots of plots, right? So you can explore all these things. They are really interesting, and see how broad it is. So many functions that are available that you can explore, and you can also find the best plot for your research paper or your presentation or your report, right? And so I'm going to use here the box plot, because box plot can easily show you the outliers like we saw yesterday. And then we can also give some labels, right? So we are going to use this labels function to do that. So let's first identify title. See, title, you have to give the name for the title, right? Title. Let's give a name, box plot of age, right? And then let's name y-axis. Now, x-axis does not need a label because it's just column, row numbers. This is age. Okay. So some people, just type this in, different rows. So people do that also, but you can also write in like, just one line. So if you run this, so it should give you a plot. Okay, so sorry. Box plot. There we go. So now, so now we can see for the age, it identifies the box plot, with the quartiles. Remember, we talked about quartiles and quantiles yesterday. So it's going to identify the quartiles, and if something is like beyond that limit, you would see, like, for example, like these ones right here, right? They look like, a little bit outside our region, right? So you can see like 75 or older, maybe like 80, 85, 90. There are some people, only a few people. If you count it, like it's just handful of people, could be like 10 people. there's like 10 people who are outside, I know, our limit, like extremely. So if this number is like, significant, if you see a lot of outliers, then you may need to consider um, different approaches, what to do with these outliers. So is there anything that you can do? So, fortunately, we don't have that many. Let's say like 10 out of like 32,561 is actually nothing. So we don't need to worry so much about that. So this is the next thing that you should do. So you can repeat this process for all your variables and see if there's any outliers. Okay. So can check the hours per week. If you want to do that, you can go ahead and do that. And for any variable here, if it is numerical, you should be able to find outliers. Okay. I mean, for any categorical variables, there's no way that you can find outliers, right? So yeah, this is the process of determining outliers. So let's see, I'm gonna name it detecting outliers using box plots, okay, for continuous variables. Okay. All right, and then similarly, you can perform, you can draw histograms for some variables, and also you can perform univariate analysis for continuous variables. You can do a histogram. So that is coming under univariate analysis. Let's see how to perform that, okay? So see, the distribution of, how the distribution is, right? So you can take a look at the distribution of values for each column, right? So we see like, okay, so what's the distribution of age? What is the distribution of the number of years of education? Likewise, you can do that for all these continuous variables, any meaningful continuous variables to do that, okay? So let's say this is, I hope you're following me. So do you need, were you able to get this box plot?
Thumbs up if you guys don't want to speak.
Yeah, I can give you some time. That's fine. We don't have to rush. Okay, good, good. All right, so let's proceed. So let's plot histogram for continuous variables. We can plot histograms, and then we can use bar plots for categorical variables, right? So we'll start with the histogram for a selected continuous variable. So here, let's say we select age, okay? So, but there's other continuous variables. So again, like ggplot, right? So mass rate, because this is going to be needed, okay? So this is one of the most important plots. So if you work with R, ggplot is like an essential. So you need to know how it works. Okay, so our data set is adult data. And we need to identify the axis. So for this, so you only have, since we are doing a histogram only has one axis. So we have to identify the x-axis. So we use the AES function, and we have to give x equals age, right? And then I'm going to use geometric histogram right here. So for histograms, we have to identify the width, bin width. For age, let's say 5, right? So that means, all these people will be put into groups of age, bins of 5, right? Like that, for example, 20 to 25, and then 25 to 30. So likewise, they will be assigned to each bin, right? So let's say it's 5. And then I'm going to fill it. Give a color, blue. And maybe we'll use, let's try this. I don't know how it's going to look, but we can try. And let's give some labels also. Give the title, histogram of age. And we have to give the x-axis name as age, right? And y-axis is going to be the frequency, right? So definitely y will be the frequency that it's computing. So frequency. Okay. Yeah. Good. So this is how the age distribution looks like, right? So is this normally distributed? So I don't know. So it doesn't look like. That's why you do the other testing, right? So you will remember we talked about few other testing that that we perform to test for normality and things. So when you go to modeling, so you may be able to verify, if especially not this, the residuals, right? So that's what we test. But this will give you an idea, how well the age is distributed. For example, your age is just concentrated into younger age groups, or all the age groups, then you may need to adjust your hypothesis accordingly, right? So you can get an idea of the distribution of your sample, right? So this would be really informative for you. Okay, so what is next? So let's do a bar plot. So what a bar plot is going to be. Let's do a bar plot for, let's select one variable. That's a good one. Let's do education and see, what it's going to be, the distribution. Bar plot for categorical variables. I'm going to use education just here, okay? Okay, again, ggplot. Now, when you start writing this, you know, you will, like, you know exactly what to do, right? So, because now you are kind of mastering it. So, bar plot also has, just the x-axis, and then you have the count in the y-axis, right? So that's what you're going to have. So AES is just going to have x-axis. So you have to give x-axis variable name. So education. Okay. So then we add the next layer. It's GOM bar. Right. So I'm gonna use fill my bars in green. Okay, so color. I'm gonna use color green. Okay. And most of the publications, I don't know if you use colors for your publications, and you, depending on that, you can change this color, like gray or something, however you want to do that. Okay, and then labs, labels. I'm going to give title bar plot for education levels. What else? Yeah, let's label X and Y axis. Then we know what they are, right? So X is gonna be education level. And then Y is gonna be the count, right? Count. Okay. I think that this should work. But did I miss something here? What did I miss here? Oh yeah. There we go. Okay, so I had one extra, it is sensitive. So R is sensitive when you have extra parentheses. So that's why it didn't work. So yeah, so this is how the count looks like. So you can see if you can make it look bigger. So you can see there's lots of people who have some high school. So your new population, most of them have high school diploma, and then the next group has the highest group is some college, and then some people also have bachelor's degrees. So you can see how educated your population is. So using this, so these things will definitely help you determine your hypothesis and make sure you're heading in the right direction. in terms of your research. Okay. So these are called univariate analysis. Okay. Because we only one thing is varying, right? So univariate means like just one, right? One thing is varying, and we just find how it varies. And then the next one is bivariate analysis. So in bivariate analysis, we just see how two variables change. So like that means like the relationship between two variables, right? So in order to determine relationship between continuous variables, we can use scatter plot. It's a very popular plot that we use in Excel, right? So let's do a scatter plot for continuous relationships. Okay, so in this case, we are just considering, let's say, for example, I'm going to use age versus hours worked. Okay. So for the scatter plot, it's pretty simple. So now you will learn how to do this ggplot, right? So first you have to give the first argument is the data set. And then we have to identify the coordinates. We use AES function. And then we have in the x-axis, I'm going to have age. And in the y-axis, I'm going to have hours per week. Okay, so you can change that. That's fine too. Hours per week. Okay. And then let's do, so remember we talked about this. So scatter plots is basically we use points, right? Geometric points, GEOs, point, yes. And you can give color, let's say like you can give color to your points, assign a color. I'm going to use purple. Or you can use whatever, red or whatever the color that you would like. Let's give a title. Scatter plot of age versus, what is it? Hours worked per week, right? Yes. And then I'm also going to name my x-axis and y-axis. X is age, and then y is going to be hours worked per week. Yeah, I think that'll do it, right? Here we go. So do you see a relationship here? I mean, it's hard to say something, right? I mean, we can see like there's lots of points here, right? So something like this, right? there's also lots of noise here, right? So noise is actually like, people say it's noise. Sometimes, I don't like that term, like, noise in data. It could not be noise, and you cannot just avoid, data just because they are not within, closer to your line, right? So I wouldn't say if there's a relationship like this because it looks pretty noisy based on the noise definition. But yeah, I wouldn't even draw it like this because it doesn't look right. So, but you can understand if there's a clear relationship. So you can get an idea. I mean, it makes sense. I mean, there's a lot of people who work during their mid ages, and then when they start working less and less when they get older, right? So this could be the general trend, but again, if you have your model like this, and I'm pretty sure you will have really like low R squared value.
Dr. Cosgola, there's a
Yeah.
request if you can share the syntax for the scatter plot.
Oh, okay. Yeah, I can share all of these actually.
Thank you.
Welcome. Okay. You should have it now. Okay, so any question, any clarifications? Okay, so let's move on. So when we have continuous categorical variables, like, for example, for example, let's say like age, right? Is a continuous variable. And then gender, right? For example, let's say like, okay, we'll take the same variable, that hours worked per week. So we need to determine between male and female if there's a difference, right? So do like women work more hours than men per week, right? So if you want to find the answer for that question, so you can find that answer using a plot with a nice plot. So we can use a box plot to do that. Okay, so let's try to do that now. Box plot for categorical. So, for example, I'm going to use here hours worked per week by gender. Okay, how it varies by gender. So that's what I'm going to find. So my question, is it different between men and women, right? So that's my objective here, okay? Just without doing any complicated work. So I'm just going to see if this is significant. I mean, not really significant if there is a difference. Okay, so we have to be careful when you use that significant word. A lot of statisticians criticize, how do you say it? Like, how do you use that word without really like going into that frame of significance, right? So you got to be careful when you deal with statisticians. I'm not a statistician, I'm an engineer, but when we deal with statisticians, they always ask how, or be careful when you use that significant word within your research. So yeah, it makes sense because it's a really specific word that has a lot of sentiments, right? Okay, so ggplot. We'll do that, and then how do we do this? So we are going to use the box plot, right? So um, we are going to give this time we are going to give for the block box plot y-axis we are going to identify um, hours per week, and in the x-axis we are going to have gender. Okay, so that's how we are going to have the box plot. So it will be like the box is going to be kind of vertical. You can also go the other way; it won't be an issue. This is just my preference. So our data set is adult data in AES. So again, I'm going to use X, gender, and Y, hours per week. And I'm going to fill the box using gender. So um, for um, for each gender, for males and females, we'll have different colors, right? So that's my expectation, because then it's clear, right? What else? Yeah, so we have to identify what kind of a plot that we have, right? So it's a box plot, so I'm not going to pass any argument there. And then let's label. It's really important to label, because otherwise people won't know what you plotted, right? So keep that in mind. Make sure you label your plots clearly and nicely. Okay. And then in x-axis, I have gender, right? So x is going to be gender. And then y is going to be hours worked per week. Okay. What else? I think that should be enough for us to see how this works. There we go. Okay. So now, do we have a story here? I'm asking a question from you. So is there something that you can say? Yeah. You don't
Yes,
have to.
it seems male works more hours than female.
Correct. Great,
Mm.
exactly. Yes, that is really nice. Yes. So that's what you see here. So see, you can say things by looking at these nice plots. So when you describe your like data, you can use these plots, right? Nicely in your presentation report or anywhere. So that's why these tools are really versatile. Okay. So what if we have you know both categorical variables, like that we need to cross them, right? So for that also we can have a contingency table. So we cannot have a plot, but we definitely can have the contingency table. That's something that we discussed earlier, so we don't have to type it, but let's just brush it up. Why not, right? So contingency table. So let's cross tab. So this is basically, people also call it cross tab. So many people, statisticians or analysts, they use this word. So we are going to use table, the base function. And so let's see education and income, right? So let's see the cross tab, if there's a difference, when you have higher education level, do you really make more money? So we can cross tab between those two because, education is a categorical variable. So is income, right? So let's do that. Education. So that's my first variable, and my second variable, data income. So if you run this, and then if you print it, it will show you what it is. Okay, so this is what you see. So yeah, you should be able to plot this also, because you can like 2 columns, and if you are creative, so you can plot these things also, like for example, if you do a little bit of like advanced plotting, like heat map or something like that, right? So that is possible. Okay, so but I'm not going to discuss all those things here because they're not really necessary here. So because we all only have 2 income categories here, so and then you can see how the education impacts. So if you visualize this, you might be able to see like even better. Okay. So this is for categorical versus categorical. Okay. Okay. So what else? What else we can do? So are we good now? So okay, I can give you a few minutes for you to catch up if you are behind.
Yes, sir. There's a request for the box plot for gender.
Oh, so you need the code, right?
Yes, sir.
Okay. Okay. Here you go. So you can also do one thing, like you can do a bar plot. It may not be really clear to see this, but sometimes people use bar plots to have to determine relationships between 2 categorical variables. So for example, in the same thing, so same the contingency table that we plot we printed here. So you can use a bar plot, but personally, I don't prefer that because sometimes it's hard to say, but sometimes it is easy to say things from the bar plot. Okay. So I can do that also. Let's do it. ggplot. Data. So we are going to give both x and y axis variables. So x is going to be education, and y is going to be income. Geometric bar. So so the position, so I am going to use not stack. So you can see that the position is stacked here, right? So let's see Stack might not work because it could be hard to see, right? But it's up to you, whatever you prefer. So I'm going to use dodge, okay? Dodge is like next to each other. So you're just dodging, you're not stacking. So that's the only argument I'm going to pass here. Position is dodge. So you can find all these things, in ggplot user manual, okay? I don't remember everything, I don't remember, but this particular thing I kind of remember a little. But you can definitely um, make that decision however you want to do it. And then let's give lab labels. Oh, sorry, I have to give other labels, right? So x-axis, let's give a label. X-axis, we have education level, right? Education level. And then y-axis, you have count. And I'm going to fill this based on my income. So let's see if it's going to help us to visualize better, okay? So fill is going to be income. So sorry, so since we are doing this, so I forgot to tell you. So this should be, the y-axis should be the fill, okay? Because like I said before, it's a little bit confusing. When you look at the plot, you might understand why we did this, okay? So I'm not using, y-axis values. Instead, I'm going to fill the colors based on the income. So let's see if this is going to make any sense. I don't personally use this, that's why, I don't really, it's not my preference, but I have seen this, some people included in their presentations and also in papers. So yeah, so you can see the color is based on income, right? So you can see education level. And fortunately, in this case, we only have two income categories, right? So, but what if we have like 10 different income categories? This is going to be really confusing and hard to really identify anything. That's why I don't prefer this. But by looking at this, yes, you can say certain things, obviously. So when you have certain degrees, so you can see you can make more money. Then you can see how many people are there with that education level and then with that income. So certain things can be said, but things get really messy when you have more than two categories. Like for income and then education, you can already see there's lots of categories. And fortunately, in this case, it's just two. So remember, like we did the fill. So fill is now based on income, okay? So, the x-axis is education and y-axis is counts. So I'm going to use fill um, as the income level. But this is going to be, sometimes you might find it really confusing, okay?
Dr. Kuskula,
Yeah?
would you like to take a break for 15 minutes?
Yes, I forgot. Let's do that.
Okay.
Yes.
Sir Brian will address your question once we return. Okay, so everyone can have a break for 15 minutes. So you guys can catch up, do what you need to do. So thank you.
Thank you.
Um, odds ratio, like the computation. If you have odds ratio, and they're wondering how to plot it with the same IV, right?
Yeah, so this contingency table actually can be used to compute odds ratio. So if you are looking at like logistic regression, so that's a different story. So that's something that I haven't discussed. Okay, but looking at using the contingency table, you can actually compute odds and odds ratio. So, but to plot the odds ratio, usually we compute log odds, and then there are different kinds of plots that we can use with the error bars, confidence intervals. So it comes under logistic regression. That's something that I haven't covered, but definitely you can use the contingency table um, and then determine the odds and also odds ratios based on the probabilities. Okay. So so now these are bivariate, right? So we consider two variables. So what if we want to look at pretty much all the variables? For example, we are going to look at all continuous variables and see how they are related with each other, right? So does anyone remember any thing that we have talked before, which can be used to look at the relationship between all variables, continuous variables? Correlation matrix, right? So we can use correlation matrix. So first, let's identify what the the continuous variables are in our data set. So this is multivariate analysis, right? Correlation matrix for continuous variables. Okay, so we have to first identify what continuous variables are. Okay, so we are going to select only continuous variables from our data. Okay, so how do we do that? So what would happen if you just do the correlation metrics for um, all variables? So you can try that. Okay, try and see what it's going to give you, and then see if it is reasonable to do it that way. Okay. So what? Hold on. I need to drink some water. Hold on. Okay, all right. So yeah, so let's identify only continuous variables. So sorry, continuous variables. So this can be just determined by using our data set. and we can use dplyr, remember, so that library, to select just continuous variables. Okay, so select function in dplyr can be used. So adult data. So we talked about this. Remember, we talked about this pipe operator earlier. So you can use that pipe operator. Okay, so I'm going to use it just to make things easy. And then we use select function. So what are our continuous variables? We have age, right? And I'm not going to use final weight because weight is not something that we are interested in, and it won't make much sense to use it. And education, number, right? And yes, of course, if you'd like, we can also include final weight and see, what the correlation is going to be. So yeah, why not, right? So education number, right? Yes, education number. And then let's do final weight. And there's also a thing called capital gain. I don't even know what it is. And capital loss. So there should be an explanation for that. Okay, so if you look at it, so I didn't have much time to look at all the variable definitions, but you can definitely look at it. Okay, so these are my continuous variables. Okay, so I'm going to just use these continuous variables for the analysis. Okay. Okay. So make sure you have the um, the function, sorry, this line executed before you use that variable. Okay, so I'm going to now use it to develop, to generate the correlation matrix. Okay, correlation matrix. So we'll use correlation function and continuous variables. Yeah, so now if you print it, it should show you all the correlations, right? Correlations between variables. So you can see, if they're correlated or not using this. Okay, so this is the correlation matrix that it just printed. So we can also visualize correlation matrix using different functions available in different packages. So I'm going to use a correlation plot available in correlation CORR plot function, CORR plot library. Okay. Okay. Here we go. So now this is the correlation matrix. See? So you can see there are some variables that are somewhat correlated with each other, right? So others are not like that significantly correlated. So looking at the correlation matrix, you can say that's a lot of things, any relationship between two continuous variables can be clearly identified here. So which would be helpful. So I'm going to give you a few minutes for you to come to this step. Let me know when you are done, okay? Oh, the syntax, okay. Okay, so are you good now? Can we proceed? Okay, I'm going to continue, okay? So we can also have a pair plot. So where you can see all continuous variables are plotted in one big plot, so that there's going to be subplots within one big plot, which shows all the relationships between each uh, continuous variable pair. Okay, so we call that pair plots. So let's say multiple continuous variables. Okay, so it's really simple. So you don't have to write a really lengthy. Obviously, you can develop it by using ggplot. This will need a lengthy, set of commands to do that. Okay, so instead you can use packages. Some people have already done that for you. Okay, so we are going to use this library, which is called. Hold on. I wrote it somewhere because I don't remember what it is. So yeah, so it's sorry, I don't remember all the libraries. So you can Google and find libraries. Okay, so you may have to install it. If it's not being installed, you may have to install this package. If it's not installed, use this command to install. If you have installed it, then you can just use this command. So this library or the package has gg pairs function that you can use. Okay, so it's really simple. You just have to give the variables, so then it will plot. It might take a while because this has it has to do some computations behind the scene. See, it's doing it. So when you see this red line here, I mean, sorry, this red button here, so indicating. Okay. Okay, so it did not work. So I don't know why. Let's see. Okay, so I'll take a look into this and then see what's wrong. So for probably something is wrong, but like I said before, I haven't used this before, but I can take a look at this and let you know next time. Okay, so I'm pretty sure maybe I can find another function to use. Maybe there's something wrong with our data, but we don't have any missing values here. But I'll take a look into that, okay? So, and see what's going on. So, I think that concludes, the basics, the data cleaning and exploration, of the data. So, using these techniques, you can explore your data, continuous categorical variables, and before that, you have to really clean your data, rename columns, and handle missing values. So those are like really essential steps that you need to follow. And then you can do this univariate, bivariate, and multivariate analysis to understand how variables are interrelated or how variables are distributed. That can be done. And then the next step is actually your analysis. So this is also an analysis, right? Remember, like multivariate, bivariate. So some people actually stop here, and they have their results ready already using some of these plots. You have your results. You can tell your story using these plots. So what we generated. So maybe for some of you, this is more than enough to write your paper. But we also learned yesterday, all kinds of other models, right? So simple linear regression, and then multiple linear regression, and then other regression types there are available, like logistic regression, um, um, and some advanced regression tools, and then also including interaction terms. So I'll leave those things to you, and you can easily learn. Once you know the basics, you can easily learn. Okay, so that should be enough for you to get things started with the data set. So hopefully you can download another set of data and then practice this. Okay, so make sure you do these steps. Maybe you have your own data set that you can work on, so that you already have studied. So in that case, you can import it into R. So these are the different types of data that you can install. So for example, if you have a data set that you work on in R, SPSS, so you can use this tool right here from SPSS, and then if it is in SAS, you can do that, and then if it is in Stata, you can do that. And in these platforms, within these platforms, you can also export the data set into text files, right? So CSV files. And then you can use import CSV command that we learned earlier. And then you just continue your work in R. So following these steps, okay? So that should be enough for this work. And so the last topic that I have for you is actually testing model prediction power and accuracy in linear regression. Okay, so this is also something that not many people do. but it could be really important in many cases. So I don't think if I can finish everything here today, but I'm thinking if I should do this on Tuesday or if you want to stop right now, because I'm not feeling really well today.
That's okay, Dr. Cosgola. We thank you
Yeah.
for all the time that you are like giving us for out of the goodness of your heart. So thank
Yeah,
you.
you're welcome. If you want to stop the recording, I can tell you. So just